Today we're going to revisit a project I did about a year ago, recreating my rig from the year 2000. Unfortunately I got a pretty messed up motherboard for the project. We have fixed several faults in it in previous videos, and today we're going to fix the last fault and finalize this sparkling green retro monster with dual Pentium 3s. So this board started out as a black screen, but as you can see it's mostly fixed now. So the only thing left to fix on this board is ID channel 1. If we connect the hard drive to ID channel 2 or to the RAID controller, the machine will boot and work proper. However, if we connect the hard drive to ID channel 1, the BIOS doesn't recognize the hard drive, and then we get a disk boot failure. Okay, so this is an ABIT VP6 board. It's the big brother of the more famous BP6. We have fixed and made a build with one of those boards too in another video. We don't have any schematics for the board, and most of the traces are inside the board, so we're left with guessing. And here's the star of the show, the VT82C686, and it has the ID controller built in, among many other things. So if we focus in on this area here and start guessing, there actually isn't all that much between the ID connectors and the south bridge. So this chip here is the high point HPT370, and it's controlling these two ID channels for the RAID. So everything in this area should be okay. These components here are probably for the real-time clock, together with the battery here. This fuse here is probably for the floppy controller. Actually it wasn't. Let's see if it's connected to the ID controller. No, it's not, so that is gonna have to remain a mystery. But it's not for the ID controller, so we can ignore it. And then we have a crystal here that is most likely connected to the south bridge. But since everything is working in that chip, except for ID channel 1, it must be good. Then we have two diodes here. Okay, this diode here is connected to ID channel 2. So how about the other diode? It's connected to ID channel 1. So that's worth checking. So we've got nothing in this direction. And 0.6. And the other diode, 0.6, and nothing. So these diodes are good. Okay, let's start at the chip end here and see what we can find. So I'm going to check all the surrounding components here and see if they are connected to any of the pins on the ID connectors. Okay, this resistor pack here is connected to ID channel 2. Now let's see if that same pin is connected to any of the resistors. Oh, it is. Okay, so this resistor pack here is connected to our troublesome channel 1. Okay, let's measure it. See if it's any good. 32 ohms. 32 ohms. 32. And 32. So this resistor pack seems good. Okay, let's poke around some more and see what we will find. Okay, so this pin here is connected to this resistor pack. So let's check that same pin on ID channel 1. Okay, it's connected to the resistor pack that we have already tested. I'll just continue until I find something more. Yeah, same thing here. So these are probably pull up or pull down resistors. Okay, this one is connected to channel 1. I'm struggling a bit here to get everything on camera. We've got nothing on this resistor pack here on two of the pins. 32, 32, 33. But on this first set up here, we're getting nothing. So that actually seems to be a faulty resistor pack. Okay, so did we just get lucky? Let's see if we can remove it with my new toy. The hot tweezers that we unboxed in last week's video. Yeah, that came right off. Okay, let's test it again off the board. So 33. Sorry, I can't get the multimeter on camera when I'm this close to the bench. 32. 32. And nothing. So that is a dead resistor pack. I wasn't expecting to find something this quickly. We're just a few minutes into the video. Well, I don't have one of these in my stash, But we can continue and do a test. So I'll add some flux to the pads and also to the resistor pack that was working. And then I'll grab the working part and move it to this position here. Oh, that didn't work too well. So you guys are seeing this with some decent magnification. But this guy here is just absolutely tiny. Okay, we've got two nasty bridges here. So I'll just remove them by dragging them away from the chip. I'll add some more flux to these empty pads. And we'll install the faulty resistor pack on these pads instead. That should give us a different fault. Not the easiest component to work with because it's so tiny. Okay, let's get rid of those bridges. Okay, I think this is pretty good. But I will of course inspect before we power the board on. Okay, both resistor packs installed. So if we check the pads where the faulty resistor was, we now have 32 ohms. The pads where the good resistor was now has absolutely nothing on one of the pairs. Okay, let's install graphics card, keyboard and mouse, and everything else. So let's connect the hard drive to channel 1 now. Here goes. Let's see if it will recognize the drive. No, it didn't show up in BIOS. Oh no, disk boot failure. Still the same fault. So we might still have multiple faults on this board. Okay, let's jump into... Oh, it recognized the hard drive. It was too quick to read. But it definitely recognized something. Let's jump into BIOS and check. Yeah, look at this. This is definitely an improvement. We had none here before. Now the BIOS can recognize the hard drive. Okay, so at least an improvement. Let's save and reboot. Yeah, here's the hard drive. It's too quick to read. But the behavior of the board definitely changed after we moved that resistor. But we still have a disk boot failure. So it's not fixed yet, obviously. So let's move the hard drive to channel 2 next. See how channel 2 behaves. It still recognizes the hard drive. Let's save and boot. Oh, channel 2 actually still works. So the machine boots. Channel 2 didn't care too much about that bad resistor. Yeah, it's still totally working. Okay, cool. So let's see if we can fix this issue. Okay, so I wonder if we can bodge an SMD resistor to the side of that resistor pack. Well, I'm not sure. These resistor packs are so tiny. Even my SMD resistors, they look huge compared to those resistor packs. Well, maybe we can make this work. Let's at least give it a try. So I'm going to use a piece of Kapton tape on the board. Oh, where did the resistor go? Seriously, where is the resistor? I am of course going to order a new resistor pack, but I don't want to stop working on this board now. I'll add some flux and some solder. Okay, so I'll check off camera, but hopefully we have bridged the bad resistor in the resistor pack with our new resistor. Actually, I couldn't make that work. That gap was just too large to bridge with solder. So I ended up soldering a regular through-hole resistor instead. So now we have 32 ohms across all the pins. Never thought I would ever repair a resistor pack. And here we are. Okay, let's connect the hard drive to channel 1. Okay, here goes. Let's jump into BIOS right away. Okay, and here's our hard drive at primary master. Let's save and exit. Okay, BIOS recognize the hard drive. Keep your fingers crossed. Come on, VP6. Yes! Hahaha! It boots! So just a tiny little resistor pack. That was the final fault with this board. If you haven't seen the previous videos about this machine, this board had a whole bunch of leaky caps and missing components on the motherboard. So this has actually been a pretty lengthy repair. And now it's finally working. Awesome! So we can finally finish this project. Wow, I wasn't expecting it to be a small resistor pack. Well, in that case, no pun intended, we can actually do the final build of this project in this video too. I wasn't expecting this when I turned the camera on. So for this project I grabbed a messed up old Chieftec Dragon case. I took it apart and resprayed it in this crazy green color. Very nice and sparkling. And it looks perfectly period correct for that motherboard. I even resprayed the drives inside. So we've got this period correct hard drive cradle, so we can easily remove the hard drive. I also resprayed the front panel on the diskette drive and a zip drive. It looks completely bunkers and at the same time pretty awesome. But as you can see, there's a large gaping hole here. And here's the reason for it. The CD-ROM drive is jammed. So when I try to eject the disk, the CD cradle just won't come out. I've had similar faults with other drives, so I think this is a very quick and easy fix. So we'll fix it in a minute. I also want to do one more upgrade to this machine, because the easiest way to get software and drivers on a Pentium III era machine is of course USB. But as you can see, this case doesn't have USB ports on the front panel. So I bought a period correct USB front panel from eBay and a cheap adapter from Amazon, so we can make it fit, because the two 3.5 inch bays are already occupied by the diskette drive and a zip drive. I'll respray these two and have them ready for the reassembly. Even the CD-ROM drive is period correct in this build. It's manufactured in September of 2000. So let's get inside and see if we can fix it. So we need to start by removing 4 screws underneath the drive. So I tried to repair this drive about a year ago, and I thought I had fixed it. But after a while, it started to give me trouble again, because at the time I wasn't aware of this weird issue. Let's push on this tab and remove the lid. And next we need to open up the door manually. Actually, this drive was a bit tricky to disassemble. I had to pull the sides out and then move the entire drive up and out this way. And if we turn the drive around, here is where I think we will find a fault. So we need to remove 1 screw on each side of this bracket. Oh no, it wasn't a fault I thought it would be. So some drives has a sticky rubberized paint on this disc here, and it tends to get stuck in this disc, and that prevents the drive to eject. But unfortunately, it's not the case with this drive. Oh crap, I thought this was an easy fix. Well, we had one easy fix so far, so I shouldn't complain. Well, in that case, I guess it's the belt. But the belt doesn't feel bad. It doesn't seem to be worn at all. So I'm not sure. I guess I'll check and see if I have a new belt. Well, sort of. This belt is slightly thinner than the original belt, but I think it's worth a try. So I'll install it and we'll test the drive. Yeah, I think this should work. Let's find out. Actually, I think I just found the fault, and I don't think it was that belt. Or perhaps I should call this a design mistake. So check out this bracket here. Look at how that thing moves. So to eject the drive, it has to move in this direction here. And if we have a look inside the lid, that plastic bracket is underneath this foam pad. You can clearly see marks that this pad here is pushing on this bracket. It probably worked fine when the drive was new, but now that it's old, there's probably too much friction here. But I'll test the drive like this, and if it gives me more trouble, I will remove this foam pad here. Okay, connected to power. Yeah, it works fine now. But it did work for a while after we made that previous disassembly. So I'm not 100% sure I can trust it. But if it gives me any more trouble, I'll just remove that foam pad. Okay, let's install a hard drive next. So back in the day I had one 100 gig Deskstar as my C drive. And then I had 4 of these 250 gig drives. That was a bit silly and pretty damn expensive. But those were the days of file sharing. I'm not going to install 5 drives in this machine. And especially not Deskstars, since all 5 of my drives died. But I have managed to find one 250 gig drive on eBay still unused in its original packaging. Strangely enough, we have already unboxed the DeskStar for this project. This was sent in by viewer tab mode, and I'm definitely going to keep this drive, but I will move it to the BP6 project, because for nostalgia I want to have a 250 gig drive in this machine. So let's unbox it. Let me smell this. Unbelievable. There you have it. A new old stock Hitachi DeskStar 250 gigs. After I had killed 5 DeskStars back in the day, I never thought I would unbox one again. But here we are. Let's hope this one lasts for a while. And we are of course going to install it in the period correct and respray drive cage. Like so. I found this drive cradle on eBay as new old stock. So the original custom screws are included. And now we can put that lid back on and install it into the machine. I also got original keys, and we actually need to use them because there is a switch inside the lock that turns the drive on. So with the drive unlocked, you can't boot the machine. Before we can install the motherboard, we need to move some of the standoffs, and our repaired motherboard can finally be installed in the case after 1 year. Okay, next we have the power supply. This is the original power supply that came with this case. It's a Chieftec branded 360 watt power supply. That should be enough for this build. For graphics, I'm going with a GeForce 256 DDR. This is the perfect period correct choice. But I think I will upgrade this card in the future, because this machine is fast enough to take advantage of a better graphics card. But for now, let's just go with period correct. I also have maxed out the RAM with 2 gigs. For sound, I'm gonna go with the classic Sound Blaster Live. Kind of an obvious choice here. The USB ports on the front panel is the old style that has an actual USB cable that needs to go out through the back and then connect to the USB port on the motherboard. That's not very elegant, so I'm going to install one of these cards instead. It has 4 extra USB ports at the back, and then it also has USB port on the inside of the machine. So this should make for a much nicer installation. Okay, it's actually the next day. So the USB panel and the 5¼ inch drive bay are now sparkling green and should match the rest of the case. I removed the PCB to avoid making a mess. So let's put it back in. Before we continue, I'd like to thank the sponsor of this video, PCB. Aside from making excellent PCBs, as we have seen in many of my videos, they also do CNC machining, 3D printing and injection molding. Perfect for prototyping and vintage computer restorations like this one. This is just a few of the projects we have built on this channel, and there are many more to come. Get an instant quote now for your next projects at PCBWay.com. Thank you PCBWay for supporting this channel. If you can't find a vintage USB panel on eBay, I'm pretty sure you can find something similar on AliExpress. Actually, this panel fits quite poorly in this adapter. I'll see if I can make it good enough. Maybe that's why it was so cheap. But that looks good enough to me. To make anything fit in this case, you need a set of the original drive rails. Okay, let's remove one of the blanks. Okay, this bay has never been used, so we need to break off this shield here. And now we can install the CD-ROM drive. Now we can feed the USB cable and the extension cable for power. See if that USB panel fits. Yeah, that looks perfect. So now I don't need to lean over the machine when I need to update some drivers or install a new game. This is super handy. Well, we still have one more bay left here. I'll see if I can find one more set of these rails. Perhaps install a second hard drive up here. Or perhaps a display that shows the speed of the fans. I'll think of something. Actually, let's make one more upgrade. and install a Noxio fan in the front panel. And it installs in one of these original fan holders. There is room for 2 fans in the front panel and 2 more 80mm fans at the back here. I'll probably install some more later and lower the speed to make it less noisy. Okay, I think we're done in here. I'll do the cable management later when the system has been properly tested. I connected the CD-ROM drive and the zip drive to channel 2 and the hard drive to channel 1. The most difficult part to find for this project was the LG Flatron display, and strangely enough the mouse I had back then. I just found this recently. Still needs to be cleaned and tested. Okay, power connected. Let's start testing stuff. So we've got dual Pentium 3's copper mine running at 1 GHz each. The display is unfortunately going to flicker until we get into Windows, because my camera can't sync to the refresh rates in BIOS. Okay, so we have the hard drive and a zip drive, but it hasn't recognized the CD-ROM drive. Oh, I just realized I think I forgot to check the jumper settings on the zip drive. So they may both be set as master. Yeah, they are both set to master. Silly mistake. So let's try cable selects. Okay, let's try again. I also did a quick test with the CD-ROM drive and it still wouldn't eject. So I removed that foam pad. Now let's try it again. Yeah, and now it works. So it was that stupid foam pad. But BIOS still doesn't seem to recognize that CD-ROM drive. Yeah, definitely nothing here. That's strange. Okay, I found the fault and it's now working. So apparently this board doesn't like cable selects. So with the CD-ROM drive set as master and a zip drive as slave, it now works perfectly. I've actually had this issue before, a very long time ago. So now I wonder if that might have been with my original VP6. That's quite possible actually. The choice of OS is kind of obvious for this board. We're going to install Windows 2000. So I'm gonna skip ahead here until we're in Windows and I can get rid of this nasty flickering. Okay, we're in. The mouse was working, but unfortunately switches are completely worn out, so it needs a restoration before we can use it. Okay, let's start testing stuff. So the CD-ROM drive and the diskette drive obviously works, since I have successfully installed Windows. Okay, let's start by testing that zip drive. Yeah, totally works. I reversed the polarity of the hard drive LED and the power LED on the motherboard, so they are working too now. Okay, let's test that USB hub next. Actually no, it doesn't seem to be working, so maybe it needs some drivers. I installed the VIA USB 1.1 driver provided by ABIT, but that didn't help. Then we also have this VIA chipset driver. Let's install this one too. VIA Service Pack 4.56 includes 4 system drivers to improve the performance and maintain the stability of the system using the VIA chipset. Okay, that's worth trying. PCI to ID bus driver, AGP driver and VIA INF driver. And we're prompted to reboot. I did a reboot after I installed those USB drivers too, but it didn't make a difference. No, still no USB stick here. Everything looks okay in the device manager, well, except for the graphics card. But we'll fix it in a minute. But the USB bus is installed and seems to be working. Okay, let's try that USB stick at the back of the motherboard. Okay, and it immediately found new hardware. Maybe that hub requires a driver, or perhaps that PCI card. Yeah, here's our USB. Totally works. I'll move the stick to that PCI card. No, it doesn't show up in Windows. So unfortunately that PCI card seems to require a special driver. That may not be an easy thing to find. Okay, I moved the USB cable coming from the hub and connected it to the motherboard directly instead of the PCI card. Let's give this a try. Yeah, I think that worked. Yeah, here it is. Okay. Okay, so the USB hub is good. Well, I don't think these cards need a driver. So it's probably broken. But I have another one, so I'll give this one a try. Okay, installing USB stuff immediately on boot. Yeah, this is totally working. So unfortunately this card is bad. Well, a card like this is really cheap. But maybe we should fix it, just for the fun of it. It only has like 10 components and nothing on the back. So maybe we'll fix it in another video. Well, with a working USB hub, it was an easy thing to install the drivers for the graphics card. Well, the last thing I remember doing on my original VP6 back in the day was to play Broken Sword the Sleeping Dragon. So I guess I'll continue where I left off decades ago and play that game this weekend. And I guess that's it for now. So I'll see you guys again next week.